All right, welcome back to another episode of Math with Mr. Young. Today we're working with 7.5 surface areas of prisms. Our standard is 6th grade geometry A, and our objective is that we're going to be able to represent prisms using nets and use nets to find surface areas of prisms. Our mathematical literacy, we have surface area and net. All right, for 7.5 surface areas of prisms, our success criteria is that we're going to be able to draw nets to represent prisms. We're also going to use those nets to find surface areas of prisms and use a formula to find the surface area of a cube and also apply surface areas of prisms to solve real life problems. All right, for our mathematical literacy, we have surface area and net. So a surface area, it's exactly like what it sounds. The area of a shape's surfaces. Okay, so you're, just like what we learned last time, finding the area of a square or a triangle or a rectangle. Okay, so now those are going to be lateral faces or bases. So we just basically find the area of each face and add them together. So we calculate the surface area of a prism, a three-dimensional figure, by adding together the area of the bases and the lateral faces. Now, that three-dimensional figure, just remember you're using the x-axis, the y-axis, and the z-axis through those three dimensions. So you're going to break that 3D figure down. I want you to imagine that you're taking that 3D figure and you're flattening it out after unfolding it, okay? So a net is used to find the surface area, and we use this net and we unfold it, we find the area for each face and add them together, okay? So in this case, you do have a square pyramid. The base is a square and it is a pyramid. All the vertices link up to one vertex up top. And if we unfold it, our square pyramid looks like that, okay? If we have a cylinder, also a three-dimensional figure, and again, if we unfold it, it's going to be flat, two circles and, that rectangle. If we have a three-dimensional figure with this rectangular prism, again, it has 6 faces, and if we unfold it, it'll be like that. And again, these are called nets when we unfold a three-dimensional figure. So one more time, step 1, what we want to do is basically use a net. So take a three-dimensional figure, unfold it. Step 2 is to find the area for each face. And then step 3 is to add them all up to find the surface area of that three-dimensional figure. All right, so as we begin, I want you guys to first understand what a three-dimensional figure is. Again, we're building off of 7.3 or 7.4, working with three-dimensional figures. So first off, we have this cube here, a three-dimensional cube. Three-dimensional because it is 3 meters tall. So we're looking here at the y-axis, okay, and that's the height, okay, 3 meters tall, or 12 meters tall, what am I saying? Next, another dimension is going to be the width. And again, that is the x-axis, okay, so how wide is that? Another dimension we have here is your z-axis, and again, this would be the depth, okay? So the z-axis here is one-dimensional, okay? So your z-axis is one-dimensional, and then again, that's the depth. We also have your y-axis. That's also one-dimensional, and that is the height, how tall, and these are all measurements, by the way. And then lastly, you have your x-axis, and that is the width, okay? Now, if we break this down, 1 plus 1 plus 1 would be 3. So that's what it means by three-dimensional. You have your x, y, and z axes, okay? So X-ray, Yankee, Zulu. So that's what makes a three-dimensional object. Now, if we were to unfold this and make it into a net, okay, we would unfold this three-dimensional figure, this cube, and we would unfold it to be a net, and it would look just like this. And again, keep in mind it's a cube. Okay, so we said it was 12 meters long and 12 meters tall, and of course that's all we really need. So 12 times 12 is going to be 144 meters squared. So all of these would be 144 meters squared. Because we multiplied the width times the height and found the area of this square. So the area of this square would be the entire area inside of it. So let me get a crayon real quick. So the whole area inside is 144 meters squared. Same for this one. Oops. Same for all of them, really. They are all 144 meters squared. Okay. Let me just finish this up. Now, how many faces do we have here? Well, first of all, I want to know how many faces we have. I want to know how many vertices we have. And I want to know how many edges we have. So first of all, we have, if we count over here, we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And of course you have 1, 2, 3, 4, 5, 6 faces. Okay, so if we count here on this net, you have 1, 2, 3, 4, 5, 6 faces. Okay, so there is a formula for a cube, and that formula is that we're going to have S here, and that's going to equal 6 times S squared. Okay, in this case, S here equals the area of this one of these squares is 144. Okay, and we multiply that. Actually, it's 12. Sorry, it's 12 squared. Okay, we substitute there. And 12 times 12 is going to be 144. And then we just multiply that times the 6 faces. And 6 times 144 will be 864. Okay, so each side, each face will equal 860, or all of them together will be 864 meters squared. So the surface area will be 864 meters squared. Okay. All right. Now again, all we are doing is finding the area on the surface of this cube. Now again, the inside of the cube would be called the volume. All right. So there you guys go, and that's how we find the area, the surface area of a cube. All right, moving on. We're going to find the surface areas of a rectangular prism right now. Again, this is a rectangular prism, because both bases, base 1 and base 2, are identical. And we have these dimensions. So part of this dimension, again, we have, let's see here. Let's say let's give it some dimensions, okay? So let's say that this is 7 inches. Let's say that maybe it's 3 inches tall and 4 inches wide. Okay, so again, let's go ahead and go over this. So it does have a height. Okay, it does have a height. So that would be the y-axis. Okay, and the height is 3 inches tall. It also has a width. Okay. And the width is the x-axis. How wide is this? And it's 4 inches wide. And then lastly, it does have a somewhat like a depth. Okay, the z-axis. Okay, again, it's 7 inches. Okay, for the depth. So again, you have x, y, and z. So these are axes, okay? This is one dimensional. Okay, your height is one dimensional. So let me write height. Your x or your y-axis. I'm sorry. This is your, not your height. What am I doing? This is your width. Okay, my apologies. This is your height, your y-axis. That's also one dimensional, and your z-axis is the depth. That's also one dimensional. Again, 1 plus 1 plus 1 equals 3. This is again a three-dimensional figure. This rectangular prism is 3 dimensions. All right, so what we're going to do first is we're going to go ahead and break this rectangular prism into a net. Okay, so let's see here. The top. Okay, it kind of looks like that. And then the back of it. And then the bottom. Okay. Let's see here. And then the side. Side would maybe be, let's see here. Top. Okay. So, okay, the side would be like that as well. 4. And again, the bottom again, or the front. All right, so again, I'm going to color code this. So the back and the front will be green, and these two are identical, which is why I'm color coding it. Both of the sides are blue, according to what we have here. And again, they're the same dimensions, so I'm color coding that. And then the bottom and the top, I'm going to color red. Okay, so there you go. So again, this is going to be 4 inches wide. Okay, this is 4 inches wide. And then of course it's 7 inches long. So this is 7 inches, this is 7 inches, this is 7 inches, this is 7 inches. And then of course it is 3 inches tall. Okay. All right. So there we go. So again, to find the area of this rectangular prism, we just know also that we have to count the vertices, the edges, and the faces. Okay. The vertices are 0 dimensional. The edges are 1 dimensional, and the faces are 2 dimensionals. Okay. So we have 8 vertices, we have 12 edges, and 6 faces. So we have 1, 2, 3, 4, 5, 6 faces that we have to find the area for, and then add them all up. All right. So let's do some quick math. So here for the red one, it's a square or a rectangle, so we use a square formula, area because base times height. Now the base here is 4 inches. The height is 7 inches tall. Okay, and then all we're gonna do is multiply. So 4 times 7 equals 28, but this is gonna be 28 inches squared. So this is 28 inches squared, this is 28 inches squared because they're identical. All right, then down here, area equals base times height because this is a blue square. Okay, so the base here is 7 inches. The height is 3 inches tall. And 7 times 3, well, 7 times 3 is going to be 21. So this is going to be 21 inches squared for the blue rectangle. So this is 21 inches squared, and this is 21 inches squared. Okay. Next, the green ones. So this is 4. Let's see here. Area equals base times height because it's a green rectangle. So this is 4 inches long for the base, and again it's 3 inches tall for the height. And 4 times 3, it does equal 12. So this would be 12 inches squared. Okay, the area of the green boxes here, 12. Now the last step we do is add them all up. Okay, so 28 plus 28, that will equal 56, and then 56 plus 21 will be 77. 77 plus 12 will be 89. 89 plus 21 again will be 110, and then 110 plus 12 will equal 122. So the surface area for this entire three-dimensional figure will be 122 inches squared. Okay, and that's the surface area, the outside area for each face of that three-dimensional rectangular prism. So again, your steps. So what you'll do first when you find the area for a rectangular prism, or any prisms for that matter, you're going to first understand that you're dealing with 3 dimensions: your x-axis, your y-axis, and your z-axis, your depth, your height, your width. Okay. Then you're going to understand that you have to count the vertices, the edges and the faces. And then what you're going to do is unfold that 3-dimensional figure into a net and find the area for each face, and then add them all up. And once you do that, you have the surface area of that 3-dimensional figure. All right, next we're going to go ahead and find the surface area of this triangular prism. Again, it is a prism because both base 1 and base 2 match. They're identical. Again, you're using the X, Y, and Z axes. So all we're going to do right now, step 1, is we're going to unfold this figure into a net. Okay, so let's unfold it. Let's see here. So we'll have a triangle down here. And then we have the back of it. Okay. Another triangle over here. Okay, and then if we unfold that, you have the back side here. And then the front side. Okay, there you go. So there is our net. Again, let's count all the vertices. So we have 1, 2, 3, 4, 5, 6 vertices. Let's count all the edges. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges, and all the faces. Okay, we have 1, 2, 3, 4, 5 faces. 1, 2, 3, 4, 5. All right, we're good to go. Again, you do have a height. That's your y-axis. You do have a width. That is your x-axis. And you do have the depth, the z-axis. All right, so 3 dimensions. All right, from here, let's just go ahead and figure this out. So this is going to be 5 centimeters tall for that triangle, and 5 centimeters wide. So this is going to be 5 centimeters and 5 centimeters. Okay, so this is also 5 centimeters, and then here this is going to be 12 centimeters. All right, so 12 centimeters. Okay, and then let's see here. Okay, that one, 12. This would be 11 centimeters. All right, there we go. So let's go and find the areas. So we're going to find the area. First of all, let's color code this. So this here is longer than the others, so I'll just color it red. These two match. The triangles match. Okay. And then these two also match. All right, so here we go. So let's find the area for that red one. So this is going to be area equals base times height because it's a square. Again, the base here is 11 centimeters and the height is 12 centimeters. And 11 times 12, let's see here, 11 times 12, that will be, I think, 132 centimeters squared. This is 132. So 11 times 12, let's see, double check. Yeah, it does equal 132. All right, and then again for the green ones, area equals base times height because they are squares. The base here is 5 centimeters. The height here is 12 centimeters. Okay, and 12 times 5, that will give us 60. So this will be 60 centimeters squared. So this is 60 and this is 60 centimeters squared each. Now here, the triangles. Formula for triangles, area equals base times height divided by 2, or half times base times height. Okay, so the base here is going to be 5 centimeters. The height 5 centimeters divided by 2. 5 times 5 equals 25. All right, divided by 2, and 25 divided by 2, that will give us 12.5 centimeters squared. So this is 12.5, 12.5. So if I were to take this triangle here and use scissors to cut it off and bring it up here, I would make a square. So 12.5 times, or plus 12.5, is going to be back to 25. Okay, so yeah, again, half of a square is a triangle. Okay, so we're going to have let's add all the faces now. So 132 plus 60 plus 60 is 120 plus 25. So I just kind of added these two together. 60 plus 20 equals 120. 12 and a half plus 12 and a half equals 25. Okay. So now we're going to add 5 plus 0 plus 2 is going to be 7. 3, 4, 5, 6, 7, and 1, 2. So the surface area for this triangular prism is going to be 277 centimeters squared. Now remember, I'm not cubing it. Even though it's 3 dimensions, because I'm not finding the volume. I'm not looking for the volume. All I'm looking for is the surface area of this triangular prism. Okay, so step 1, make it into a net. Step 2 would be to find the areas for each face. Step 3 is to add them all up, and then you'll have the surface area. All right, good to go. All right, my friends, that concludes our presentation today for 7.5 surface areas of prisms. Now, by now, you should be able to draw nets to represent prisms and also use those nets to find a surface area of that prism, and also use the formula to find the surface area of a cube. Remember, a cube has 6 equal faces, so 6 equal sides. All right, so just find the area for one of those and just multiply by 6. Wham, bam, that's it. And then, of course, use these the knowledge you have about finding surface areas of prisms, and you could use that to solve real life problems. For example, if you're painting a doghouse, or if you're painting a house, or building something. Okay, so you can find a surface area of many things. All right, so there you go, and that's all I have for you guys today. And now get out there. Don't forget your mathematical literacy. That surface area, one more time. It's basically the area of a shape's surfaces, so all the faces. Calculate it, find an area for each face, add them all up, and again, a net is when we unfold a 3-dimensional figure and find an area for each one of these faces and then add them all up to find a surface area. All right, thank you guys. Have a good day.